Today I want to talk about DoS attacks. And as we do things here in PancakesCon, excuse me, I'm going to start with the security aspect. Can we prevent DoS attacks on our apps? Now, for those of you who are older than me, you might be wondering why I'm talking about a several decades old operating system. I'm not. I'm talking about this kind of DoS, short for denial of service attack. Taken from we'll take the formal definition from the OWASP site. The denial of service attack is focused on making a resource, site, application, server, unavailable for the purpose it was designed. And then this goes on for another 2 or 3 pages, which I saved you the trouble. But this is the DoS I'm going to talk about today. Just to clarify, often when we think about DoS, or at least when we hear about DoS, we hear about DDoS, distributed denial of service, which essentially means you're hitting the application or site or whatever with a bazillion requests. And yes, that is a technical term, a bazillion requests from a bazillion different sources, hence distributed, and you just overload it until it's unresponsive. That is most definitely a valid form of attack. It's completely not my wheelhouse. I'm an application security guy. And the prevention of DDoS, of this type of attack, is usually outside the core application security aspect, and it's more in the ops world of rate limits and whitelisting and all sorts of fun stuff like that, which is totally awesome, and I unfortunately am not smart enough to be really good at. So instead, I want to focus on the core, on the application, and preventing DoS attacks in the application layer. Now, the one thing that is really important to remember, or to keep in the front of your mind when thinking about DoS, is that it's not about speed. Now, most people's instinct when they hear about DoS and denial of service and having things take too long and consume too much memory is to say, okay, great, we'll optimize everything, we'll make everything super fast and super lean and super efficient, and then we won't have a DoS problem. It's an understandable thought, but more often than not, it's just wrong. First of all, I mean, if whatever you can optimize, by all means, go ahead and do so. You will make the world a better place. But chances are this isn't the best usage of your time. But more to the point, the denial of service isn't just about speed, isn't intrinsically about doing things faster or slower, because maybe something takes half an hour to respond, and that's fine because that's the way it was designed. Denial of service attacks are about consuming resources and blocking others. So it's not necessarily about the speed, it's about the effect you have in other participants. Okay, that was a lot of technobabble. Let's see a couple of examples, and hopefully this will be a bit clearer. So how do we DoS an application? First instinct, if our application parses something, let's try and overload that parser. So we have here a very simple application in Node.js. Actually, probably should have said this earlier. All of my code samples here are going to be in Node.js. Well, first of all, because that's my focus nowadays. Second, because it's quite often really straightforward to read, and even if you aren't a Node.js or JavaScript expert, it's pretty understandable and pretty easy to translate in your mind to code sample of your preferred language or ecosystem. But even if you don't do that, these aren't real applications. They're intentionally vulnerable snippets. I will explain them as we go by, so don't get freaked out by the scary Node.js code. So we have a so-called application here. It takes a JSON payload, passes it, and returns back the number of keys in this payload. And naturally, we would think that the larger the payload is, the more we overload this parser and make it consume more resources, etc. Well, how bad is this? So, as my wife likes to say, I am worse than a nerd. I'm a nerd with a degree in economics. So, how bad is it? I put it on a graph. And we can see that other than some sample errors, probably due to cache misses or whatever, or paging, more probably. How bad is this? This is linearly bad. The larger the payload is, the longer it takes to pass. Now, remember, we said DoS isn't about speed. So the problem here isn't that it takes almost 4 minutes, 3.5 minutes to pass a kilobyte of JSON. The problem is that in a lot of modern web frameworks, specifically we see this in Node.js, you have a single event loop, which is supposed to get the request, extract the parameters, do its thing, and then do any heavy processing or I/O in a worker thread and go back to responding to more requests. JSON parsing, when done like this, is done on the event loop. So you send out a big request, it takes 4, 5, 10, whatever minutes to answer, not a problem. Or at least, well, seconds, not minutes. I don't know how to read my own graphs. But the fact it takes 5 seconds isn't the problem. The fact that your application can't answer any other request while handling this is the problem. And that's the denial of service effect, where you deny service from other legitimate requests. So what can we do about it as application developers who are conscious of security? Well, quite a bit. First of all, kind of off the top of our heads, don't allow tainted or user-controlled input to be passed by such a parser. Well, nice fantasy, not usually realistic, right? If most applications, the whole reason for their existence is to get input, do something with it, and return output. So if you can't handle input, what are we even doing here? What you can do very easily, quite often, is just limit its size. How do we want to limit it? I don't know. You tell me. The key here is to get to know your application, get to know the legitimate use cases, maybe add some buffer, but understand the legitimate use cases and cap the application around there. We see this quite often, for instance, in SPAs, where you have a heavy, rich front end that takes the user input, meshes it around. At the end of the day, it sends a JSON to the backend and gets a response. That's fine. If my input is a form for username and password authentication, username is, I don't know, 10 characters. Password, we were just told in the previous lecture, it can be up to 64 characters. Put that together, 78. a bit of overhead for the JSON format. 100 bytes. Absolutely no reason that that backend handler should accept a 2 meg default input. Get to know your application, cap the inputs at a reasonable size. And of course, since we said that the main issue is blocking an event loop, blocking others from having the requests served, excuse me, throw this into the background. There's tons of ways of doing this. These are, of course, in Node.js specific examples like BFJ or JSON stream, but in whatever ecosystem you're working in, there will be a way to do this. But okay, this was kind of boring. It was kind of basic, linear dependency. Let's see something a bit more drastic. So again, we have a quote-unquote application here, intentionally vulnerable, of course. Don't copy this code anywhere. So this code takes an XML payload, passes it, and returns back how many child nodes were in the payload. Well, seems benign, but what if I tell you there's a bomb threat in this application? Okay, no, I'm sorry, bomb threat was way too serious. PancakesCon is supposed to be fun. My mistake. Instead of talking about bombs, let's have a laugh. In fact, let's have 1 billion laughs. So this is an example of a payload. This is the XML variant of an attack called the billion laughs attack. And this is a form of payload, or a form of XML bomb attack. What we see here is a relatively small payload that takes advantage of the XML format's ability to define entities and then reference them. So we have the definition of the lol0 entity. It's then referenced in the lol1 entity in the third line, and then it's referenced recursively as the lines go on. So as you can imagine, if we expand all of these entities, we start out with a really small payload, but it bombs up, hence the name, to something huge in memory. Now, how bad is it? Again, being a nerd with a degree in economics, I just graphed this out. Starts okay, 1, 2, 3, 4 levels. In the 5th level, we start seeing a noticeable difference between the size of the payload and the size it expands or bombs up to in memory. 6 levels, it's quite noticeable. In 7 levels, the payload itself is 650 bytes. It bombs up to 29 megs in memory. And it continues exponentially. I tried to put the 8th level on the graph here, and it just made everything else too small to notice. So I stopped at 7. What can we do about this? Again, quite a bit. So if the threat here, if we have a bomb threat in XML parsing, well, don't use XML, of course, if you can. If the entire reason your application exists is to get XML input from some other microservice or hand XML output to some other microservice, you can't really avoid XMLs. On the same note, if you can disallow tainted input or user-controlled input in your XML parsing, again, problem solved, but again, quite often not the case. In the realm of more realistic solutions, XML is, again, a technical term, a smarty pants format. It has a ton of functionality that more often than not, you do not need. So if you don't need to expand entities, just disable this feature. I think most ecosystems have an XML parser that's just a wrapper on top of the libxml library. So this is how you'd configure it for libxml, but if you have a different parser, find your configuration values. And of course, this same way we treat any injection attack, sanitize your inputs. Don't allow stuff you don't excuse me, you don't expect, like entities if you don't want them. Also, kind of, when I did this presentation at my previous job, one of the comments, well, wasn't in English, but boiled down to something like, okay, boomer, who uses XML anymore? Well, fair enough if you don't, but what are cool kids using today? YAML? YAML has the exact same problem. Of course, different config values and different parsers, but YAML also allows defining entities, and depending on your parser, you can also bomb a YAML parser. So the concept stands. But enough about parsing. Let's talk about something a bit different. I mean, regexes, okay? Every programmer knows regexes. Every programmer used regexes at least sometime in their career. And I think absolutely no programmer likes them, but we all still use them. So again, a vulnerable application snippet, again, intentionally vulnerable, do not paste this anywhere, but very straightforward. It gets a regex, it takes a text, it tests if they match, and returns some indication if they do or don't. Well, regexes are also regexes are an extremely powerful tool, ridiculously powerful. Sometimes, also again here too smart for their own good. So consider regex like the regex in the comments, brackets, a plus on all of that. For those of you who aren't fluent regex readers, this means a string of one or more A's, one or more times, which is a very, excuse the language, stupid way of saying a whole long bunch of A's. This is a functionality called backtracking, which has its legitimate use cases. This is not one of them, again, because we could have expressed this in a much simpler regex. But why is backtracking bad for us? So just think about a poor regex engine that needs to evaluate a string of 10 characters against this regex. So of course, there's optimizations and pruning, etc. But in a nutshell, you'll have to see, could it be a string of 1A followed by a string of 9As? Two strings of 1A followed by a string of 8As? A string of 2As followed by a string of 8As? And so on and so forth. So again, how bad can this be? Really, really bad, really, really fast. I graphed out the function of the time it takes to evaluate such a regex against a string made up of a series of A's and B at the end of it. It worked kind of okay until 26, 7, maybe 8 A's. In 29, 30 A's, it really started kicking up. At 33 A's, it took almost a minute. 35 A's, it took almost 5 minutes. At 36 A's, excuse me, I had to kill my benchmark because it was taking up so much CPU time. It was making my music hop. And if there's something that's really annoying, is hopping music. what can we do about this? First of all, if you don't speak fluent regex, check your regexes. If you have regexes baked into your code, I'm not going to recommend any specific tooling, but generally speaking, SAST, static analysis tools, do a really good job at finding bad regexes. As always, considering tainted or user input, don't allow tainted input as your regex if you can. Not always possible, especially if you have a functionality to get a wildcard search string from the user or something like that. But if you can, just avoid that. Also, if you can, don't allow user-controlled input to be evaluated by a regex you know might be dodgy. Again, if you can. If you can't avoid this, at the very least, use length limits. It's a really cheap, really fast check that you can apply before even going to a regex. And again, if you can, think about alternatives. Regexes are kind of the go-to for format matching, etc. There are alternatives that are not vulnerable to DoS, to regex denial of service. So there's a saying that people will take 1 or 2 sentences away from a talk. What do I want all of you to take away about DoS attacks? First of all, DoS attacks aren't flashy. They aren't good demos. We can't show user data exploration or takeovers or remote code execution, but they are relatively easy to pull off and can have really bad impact. So think about your denial of service. Think about how the system can be used, by who, with what input, and what input will bring it to a grinding halt. And with that, I want to pivot a bit away from application security, because we all care very deeply about our applications and preventing them from denial of service. But there's something we want to protect much more than that: our days. Can we prevent our days being DOSed? Well, if we're going to talk about prevention, let's first talk about how can our day be DOSed? Well, really easy. You want to ruin someone's day? Let's have a meeting about it. Meetings are the abject worst. So I consider myself a relative novice in security, definitely compared to the other speakers here. I've been doing this for the last 5-6 years. But I've been working in tech for, I think, 23 years. And I've been a functioning adult for a bit longer than that. I've been a manager for, I think, most of my career, about 2/3. And I had a hell of a lot of meetings. So I feel quite qualified to say meetings are the abject worst. And why are they the worst? Well, as a functioning adult, especially in our industry, we have a fantastic privilege of managing our day. We know when we're high on energy, we know when we're low on energy, we know when we're communicative and open to discussion, and we know when we want to focus, and we can build our day accordingly. A meeting, if you aren't the one scheduling it, breaks all of this. It just gets slammed down, usually by someone higher up than you. You have to attend it, and there goes your plan. Denial of service on your day. And the kind of most irritating point about this is that the payoff is really small. I'm I will claim that for the immense price of ruining your day, you get really little benefit. Why is that? Well, for a number of reasons. First of all, meetings have a limited time. At least if the person running the meeting is competent, a meeting has a set start time and a set end time. This in itself is not a problem. This in itself is actually the one saving grace of having a meeting. If we schedule a meeting between 3 o'clock and 4 o'clock, if the person running it is competent, by 3:57, we'll have a decision on what we're going to do. By 3:59, everyone will know what their action items are towards this goal. And by 4 on the dot, will be out the door. That's an advantage. Problem is, if we cap the frame, there's only so many words you can say within an allotted time frame. And these words don't get distributed equally. Naturally, some people are more extroverted. Some people feel more comfortable speaking up. Some people, and this usually correlates with Frank, will speak more of their fair share of the time with less of their fair share of good ideas. But if we want to cap the meeting at a time, when the time is due, we'll be done. Will all ideas get their fair shot? Probably not. So will we get a decision on time? Yes, if we're competent at running a meeting. Will this be the best decision? Almost certainly not. And even worse than making subpar decisions quite often, I think there's a bigger problem. I'll claim that meetings, by their very essence, are exclusionary. Now, I'd like to hope that in this time and age, no one will set out to explicitly or intentionally exclude anyone, or won't set up a meeting for the express purpose of excluding anyone. But by the very nature of having a meeting, you will exclude some people. Why does this happen? Well, for a bunch of reasons. First of all, we have what I like to call the time zone problem. So if you work in a global organization with people from all around the world, or if you have customers or partners from the places, you should be aware of something called time zones, right? Different places in the world have different times. If it's now about, I think, 4:45 over in Chicago, it's about 9:45 over here in Israel. So whenever we set a time for a meeting, we have the chance that someone will have to compromise. Someone will have to make adjustments to their day in order to attend. But it's not just compromising. Quite often, it's not about the compromises you're willing to make, but about the actual ability to attend. And here's the kicker. It doesn't only happen if you have a geographically diverse team. In my team, we have 2 people that live about 20 minutes ride from each other, 20 minutes drive from each other, but they are effectively living in different time zones. One of them has 3 kids. He wakes up usually at around 6:30, wakes everyone up, The whole family has breakfast together. They plan out their day. He drops 2 of the kids off at school. His wife drops the other one off at her school on the way to work, and he starts his day at about 7:30. The other person, wow, English is hard today, excuse me. The other person wakes up much later, goes down to the beach, has a surf, goes back home, takes a shower, changes, gets to work at about 10:30, and then stays on a bit longer. Both of these are fine. Both of these are completely valid. But if we have a meeting at 9 a.m., it's fine for one of them, and the other one needs to really change around his day. And if we have a meeting at, I don't know, 4:30 p.m., it's fine for one, but the other one is constantly looking at his watch and waiting to be done with this day and get home. So they can both, even if they both attend, they aren't really in the same level of energy, the same level of commitment. They aren't both of them really there as much. And this isn't about geography, right? 20 minutes drive from one person's house to that. But let's say you don't have this problem. There are, there are other exclusionary traits to meetings. Second problem, which I like to mention, is the language problem, the language barrier. So again, this happens more often in large companies, global companies, where you have participants from different countries, partners in different countries, customers in different countries, but not necessarily. In any case, if we're having a meeting, we obviously all speak the same language. That's kind of a given, but usually English in global companies. But being able to speak a language and being able to speak a language well and fully articulate yourself in that language are 2 very different things. For people who are forced to participate in their 2nd, 3rd, 4th, 5th language, and I've had meetings in English with people from all of these numbers, ranging from 1st down to 5th. There's a huge difference in being okay in a language, being able to watch TV in a language, traveling to the States and asking where the bathroom is. That's a fair level of English. And being able to have a deep technical meeting and bring up your ideas, right? Explain them, defend them. It's really not the same level of comfort with language. This, by the way, also does not only happen in global companies. Same problem happens within the same country, in the same language, when some of the people in the meeting weren't born in that country. They emigrated to it later in life and picked up the language later. Or even to a lesser degree, if their parents immigrated to that country and at home they speak whatever language their parents speak, but outside of home they speak whatever language everyone else speaks in that meeting, for argument's sake, English. Still a noticeable difference quite often in the ability to communicate. Drawing on these 2, the 3rd problem we have intrinsically with the concept of meetings is what I call the like me problem. There's a ton of research that shows that people generally speak up when they feel comfortable, and people generally feel comfortable when they're in a group of people who are quote unquote like them, whatever being like me means for anyone individually, completely subjective. But generally speaking, the more noticeable whatever perceived differences are. For instance, and this is really sad, but we see it quite a lot in tech, if there's one woman in a room full of white dudes, statistically, these people will feel less comfortable and will speak up less. Are their ideas any worse? Of course not. Do the same ideas get the same share of the meeting? Probably not, because the people who feel that they're different for whatever personal subjective reason tend to speak up less. What do we do about this? Going back to the concept of the talk, we default to async. Async communication, written async communication, is the great equalizer. I usually like to say that there are no simple solutions and no silver bullets, no one-size-fits-all solutions. Replacing a meeting, any meeting, with asynchronous written communication is as close as you get to a silver bullet. It negates almost all of the problems we discussed here. First of all, with the caveat that you need to buy into the concept of asynchronicity. It will not be as fast as grabbing 4 people from the cubicles, going to your conference room and hammering out a discussion in half an hour. It won't do that. If you're willing to lean into this, if you're willing to have a longer discussion over written medium, a lot of these problems go away. First of all, you aren't imposing on anyone's day. Right? I send out an email, everyone else can answer it when they're comfortable, when they are in the right mindset and the right energy to communicate. We don't have as much of a problem of everyone trying to clamor in and fit in their 2 cents in half an hour of a meeting, because we don't have a time limit on this, or at least not a firm time limit. And moreover, the fact that I write 200 or 2,000 words of a reply doesn't mean I'm taking away 2,000 words from anyone else. We can both write long replies. Time zones problem goes away because you answer when it fits your day. The language barrier doesn't disappear completely, but it's greatly diminished, especially for people who communicate in a second language. Written communication is quite often much easier than verbal communication. You can stop to think, you can look up a big word you aren't sure about, you can ask your mom. The like me problem is, again, much reduced. The participants will be as diverse or as non-diverse as they were in a meeting, but it's not in your face anymore. It's just names behind the emails. You aren't sitting in a room thinking, hey, no one else here looks like me, and everyone else seem to be okay with talking, and no one has a horrible accent like I do. So the diversity is still there, but it's greatly reduced. It's not in your face as much. So if you've ever heard the idiom, this meeting should have been an email, it absolutely should. Which meeting? All of them. Almost universally, all of them. They are really real and rare cases where they shouldn't, but I do not want to DoS the next speaker's time, so I'll leave it as that. If any of this struck you as interesting, please don't be a stranger. I am not a hard person to find. Reach out to me. Let's continue this conversation. And if there are any questions, I'd be glad to take them.
Well, thank you, Allon. So yeah, let's go quickly. So I did get one question from Shannon. Any recommendations for bringing more asynchronous ideas into a team? You can use tools that don't always solve problems, but sometimes they can give a good base. But I guess how would you, push the idea? Don't use meetings, but rather use asynchronous communication. How have you done that?
Well, first of all, if you're the one scheduling meetings, just stop, send out emails instead, or put up a shared document in Confluence or Google Docs or SharePoint or whatever you're using.
Mm-hmm.
If you are forced into a meeting, absolutely insist that this will be followed up in writing, because we don't remember what we talk about. And then once you have this anchor, you can usually build off of it. So this is a summary, reply all, okay, that's a great point, but I think we can do X, Y, Z, and you start building on that. Thank you for having me, and thanks everyone who listened. Have a great day.